Welcome. In this video, I'm going to work through the VCAA 2023 Specialist Maths exam, exam 2 from May 2023. So this is the Northern Hemisphere exam. I'm just going to do the multi-choice section, and just for fun, I'm just going to do it using my CAS calculator, and I'm not going to pick up a pen or paper. Not that I recommend you do this. Of course, you want to use a pen and paper, but you also want to make a really good use of your CAS calculator, whether it's a TI-nspire or the ClassPad or the Mathematica or whatever you are using. So let's start from question 1. The implied domain and range of this function, sine of inverse cos 1 minus 2x. Okay, so this is a good one for the TI-nspire because we have the domain function. So the domain for inverse cos 1 minus 2x, and then we want to do the sine of that. I think we need the comma x in there, is 0 to 1. Okay, so then we're automatically down to options A and D. Then we need to work out, does this thing go from 0 to 1 or negative 1 to 1? And in order to do that, I probably could graph it. But what I could probably also do is just sub in the endpoints. That probably give it away. When x is 0, I'm at 0. When x is 1, I'm back at 0. And so when x is half, we're positive as well. So I don't think the function is going to the negatives. If you want to be super sure, you could sketch a quick graph. And there you are. So question 1, we are option A, off to a good start. Next one, another trig and another composite function. So we've got an arc sine or inverse sine. Why are we calling arc sine here and inverse cos there? It's a bit weird. Anyway. So arc sine is obviously inverse sine. G of x is some linear function, and we've got f of g of x. So we're putting this linear inside this inverse sine function. And this is what we get. So finding that values of a and b. So to do this one, we could obviously just graph all of these options. If I have inverse sine of a half x plus a half, or negative half x minus a half, and just basically try all the options, see which one gives us what we want. Again, like we know we have to go through this endpoint negative 1 comma pi on 2. So if I just use the function inverse sine, half x plus a half, and check when x is negative 1, do I get up to pi on 2? No, I do not. So that's no good. Could check then negative a half, negative a half. Still, I'm at 0, so that is no good. Negative a half. A is negative a half, and B is a half. So negative a half x plus a half. 90. Well, I think I'm in degrees mode there, so probably want to change that to radians. But that would get me to positive pi on 2. So option C is possible. Well, I want when x is 1, y to be 0. So let's just check that. It does work. And when x is 3, hopefully, I should be negative pi on 2. So that's looking pretty good. Maybe I'll just rule out these options by changing the b value to 1 and showing that neither of those go through the right point. So what's going on there? Well, I guess that's undefined under the real number, so it's giving us a complex number. So option 2, that took a little bit longer, but that is question 2 is option C. Of course, we could just sketch a graph of that one. And the graph of this one does not have, this might be a good one to just sketch it and have a look. So mod x minus 1 over x squared minus 1. Just go back and reuse this page. The modular sign is just under this button here. Mod x minus 1 over x squared minus 1. And what do we have? Do we have a domain of reals excluding negative 1 and 1? I think we do, and that makes sense looking at our denominator. Do we have a horizontal asymptote? We do. Do we have a vertical asymptote? We do at negative 1. A vertical axis intercept? Yes, of course. A local maximum turning point? No, we do not. So we do have those 4. We do not have E, so option E is correct for that one. A straight up CAS question. All right, this one looks a little bit interesting. Z is A plus BI, A and B are real numbers, positive, arg z plus I z conjugate. Okay, so on the CAS, we can define z to be a plus bi. And this is often a useful trick for complex numbers. Don't forget though, we can't just use this I, we need to use this I. And then pretty much just type this in. Arg, we do have an angle function, so it's under number tools, complex number tools, polar angle. And we want z plus I times z conjugate. So z, see, it comes up bold because we've defined it. I, again, we need to use this I. And z conjugate, conjugate again is under that menu, but I can just type CONJ. Now it's giving me this sign, this sign function. Now what that is basically going to give you 1 if these things are positive. So if I type in sine of 7, it would just give me 1. If I type in sine of 777 or whatever, it would give me 1. If I put a negative number in there, it's going to give me -1. So in this case, well, because I know A and B are positive, that should give me, that should just give me 1. So what I'm going to get is pi on 2 minus pi on 4, which is just pi on 4. I think probably if we put that domain restrictions into the what we're evaluating here, so given A is greater than 0 and given B is greater than 0, yeah, so the CAS is actually, the TI-nspire is actually quite clever there, and it can identify that in that case, well, the sign is positive, so we just want pi on 4. So question 4, answer is D. Again, like that on complex number questions, that function defining z as a plus bi or x plus yi can be pretty useful if you don't want to think too much. But of course, thinking is good, has its place. Question 5, 2 plus 4i is a root. And we want to find the real root. So we can use conjugate root theorem because all the coefficients are real numbers. So 2 plus 4i is a root, 2 minus 4i would be a root. We only have one more root. So what I will probably do here is I know that the factors will be z minus 2 minus 4i. Z minus 2 minus, okay, in this case, I don't want that definition of z. So get rid of that using a del var or menu actions, delete variable. And what I want to do is probably in expanded form, give the polynomial z minus 2 minus 4i, z minus 2 plus 4i being the conjugate. And then my real factor is just going to be like z minus b or something. Okay, I know it's a 1z because I've got a 1z cubed as my leading term there. So if I expand all that out, and then I'm trying to match that up with this polynomial here, which has a constant term of 5. So basically that negative 20b must be equal to 5. You probably don't need a CAS to solve the value of b there, but that's going to be -1/4. Okay, so question 5, option B, we're 1/4 of the way through. Another complex numbers question, we've got a set S. Points equidistant from these 2 points, and we want to find that in Cartesian form. Again, this is a good one to use the define z as x plus yi, which I deleted before, but I can probably find it up here somewhere. Or just retype it. Actually, I think I'll use x plus yi here because I've got x's and y's in my answer. And then set this up as an equation. So the distance of z minus, so z from 1 plus 2i must be equal to the distance of z from -2 plus I. Now, because I've defined z as x plus yi, that is going to all just be re-expressed in terms of x and y. And what I want to do here is figure out which one of these is correct. I know this is actually going to be a linear graph because this is the perpendicular bisector of these 2 points. It's a straight line. So I'm going to solve that for y. And there we are, y is equal to -3x. So that again, that's a good use case for that defining z as x plus yi. And so in that case, question 6, option is E. This one, definite integral. Okay, so every year we have a definite integral question like this, and pretty much we can always solve these without thinking, you know, just by typing this in, get a decimal, type all of these in, get a decimal. And so, you know, I can do these use substitutions, believe it or not, but gonna do it the hack way, just to show that you can. So cos x all cubed, that's like cos x on the CAS all cubed, sine x all squared, and so that should be equal to 0.1333. So whichever one of these is also equal to that is going to be the same definite integral. You know, we're going to make a u substitution, so the terminals are going to change. So I'm not going to try B or E. I'm looking at either A, C, or D. So let's just try A first. Menu 4-3. 0 to 1, u to the 4 minus u squared. du, doesn't matter what u is. If this has the same value, it does not. So that is not the same definite integral, but if I flip the terminals or reverse the sign on the integrand there, so u squared minus u to the 4, that should give me what I want. And there we are, so option C. Yeah, that method of just evaluating the definite integral, evaluating the u substitutions would work every time. The only time is if, we've got like variables in our terminal. In that case, we would get an expression in terms of that variable, not just a decimal. You can hack that as well just by making up values for the variable, but I mean, you've got to learn u substitutions anyway. I'm just showing you another way of doing it. This question, so slope fields, and we're picking one of these. So we can sketch these on the CAS, so I guess that's probably what I should do because this is like a CAS explainer. But generally what I do with these ones is look for patterns, like, along the line where y is equal to 0, we're getting a 0 gradient. So I would expect the y to be on the numerator, and as close to the line x is equal to 0, we're getting an infinite gradient, except at the origin. So I would expect the x to be on the denominator, well, which it is at every time. The squareds, as for the squareds, probably looking at the symmetry. So because like the square of a negative is always a positive, like option B there would always be giving me a positive gradient, but I can see that that's not the case, getting negative gradient like here and here. In fact, we're getting a negative gradient whenever x is negative. Whenever x is negative, we're getting a negative gradient. So yeah, so we'll be looking at option C there because it doesn't matter what y is, we just need x to be negative. But let's actually sketch it on the CAS and see. So we will go to graph and we'll go graph, what do we go? Graph type. Where's graph type? Oh yeah, graph entry differential equation. Okay, so we want y1 to be the derivative of y, this is the derivative of y1 dash with the dash very far away, to be y squared over x. So now I believe I need to use y1 squared over x and see what that does. I could probably zoom out a bit, but it looks right. Okay, so I've got the negative gradient on the left, the positive gradient on the right. So I'll be going with option C there. Okay. This is the length of a curve question. And we're given the integral here, we need to figure out the curve. So the formula we're using is square root, integral of square root 1 plus dy dx all squared. So this part is the dy dx all squared. So basically, this I probably would use a pen and paper in this case. So dy dx will be equal to the square root of that, which would be 1 over 2x squared. And what I want to do is basically find y. So I'm going to integrate dy dx. So I'm going to integrate the square root of this term, which would be 1 over 2x squared. And that gives me -1. So that would be my y value, okay? Because my function for y. If I was to differentiate that, I'll get back to here as dy dx, and squaring it, give back this. Keep in mind, this form of the arc length formula is actually not on the 2023 formula sheet. You've only got the parametric form. So whether that means you would not be expected to use this form, I would hope so, given it's not on the formula sheet, but it doesn't hurt to know it, I guess. So option D there. Coming up to halfway, and we have question 10, a related rates question. No, really, I should be using a pen and paper for this. I want to write down step by step what's going on. But given that I promised I wouldn't, I will not. This is the dVdH. This is the VDT, because this is the water flowing at a rate, and we can tell from the units is meters cubed per hour. This is a dVdt. I want to find dHdt, so I want to probably multiply dVdt by dHdV. So I then need dVdH. Okay, so given that this is a cone, I know V is equal to 1/3 times pi r squared h. I want this in terms of h because all my answers are in terms of h. And I know that r and h are in this relationship where the height is double the radius. So the radius is going to be half the height, okay? Because wherever I am, I'm always going to be similar to this big triangle here, which has a height of 2 and a radius of, or a base length here of 1. So if I replace that r now with h over 2, j over 2, h over 2, this is my volume in terms of h. I want to get dVdH, so I'm going to differentiate that. I mean, you can easily differentiate that by hand. dVdH of this is going to be 3 pi h squared on 12 or pi h squared on 4. And this is dVdH. What I want is dV by dVdt. So I'm going to take the reciprocal of that and then multiply that by my dVdt, which was 0.5 square root h. And why am I in decimal mode? Do it again. Okay, so we get 2 over pi h to the 3 on 2. One's positive and one is negative. My water is flowing out. More water is flowing out and dHdt is given by. Okay, the height should be decreasing. So sorry, what I should have done here is put a negative in front of that because this is the rate at which is flowing out. The volume should actually be decreasing. So yeah, it should be negative. So just watch out for that. And this question 10 should be option E. Vector functions question. CAS is pretty good for these. We define them using a matrix. You can either use a row or a column, but I like to use a row because you basically just, find your square bracket and then comma, 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 it'll make your matrix for you. So here I can define this function as r of t. Oh, get that out of the bracket. And then I only want here 2 values. One is 5 plus 2 cosine t. Use a comma to separate them. The next one is 3 bracket 1 plus sine t. Sine t. Okay, so what I probably would do again is just check values, check endpoints, rule out options by elimination. So I know that the t value should go between pi on 2 and 3 pi on 2. So, and I've got an arrow as well. So for example, this should be the point when t is pi on 2. This should be the point where t is 3 pi on 2. So by just doing r of pi on 2, I know that I should be starting at the point 5, 6 and 3 pi and 2, ending at the point 5, 0. So no, that's the opposite, okay? Because I should be starting at 5, 6 and ending at 5, 0. So here we are. That's the only one that works. Option E. Another vector functions question. We've got the position. We want to find the maximum speed. So the speed, we want to firstly find the velocity. I mean, you know, we can differentiate that by hands to get the velocity, but again, I'll just do it on the CAS. I'll redefine r here. In this case, I want sine 3t. And -2 cosine 3t. Okay, so we want to differentiate that. So find our derivative template. Differentiate r of t. That'll be the velocity. To find the speed, we want to find the length of that vector, which on the CAS is the norm. So under matrix and vector, we've got norm, or we just type norm, take the norm of this, and we get this function. And this is what we want to find the maximum of to find the maximum speed. We could do f max, but it's going to give us a t value, which we then have to sub back in. I mean, looking at that, you know, sine 3t has a maximum of 1. So given that we just got inside there 1 plus 3 sine squared, that's going to have a maximum when that sine is 1. We could sketch it, but, well, let's sketch it. Just copy it, paste it into a graph. Maybe use a new one. I can't use t, I have to use x on the graphs page, but we should see it's got a maximum up here at 6. Okay, just in case you didn't believe me. This vectors question is a little bit trickier. I mean, we've got the vector resolute of this vector in the direction of some unknown vector b, and the vector resolute is this. Okay, so we're going to find the value of d. So, you know, there's a few ways that we could do this, but what I think about is like the vector b that I'm going in the direction of must be in the same direction of this vector, okay? Because this is the vector resolute. It must be parallel to b. And actually, it doesn't matter about the length of b, because the length is going to come from, you know, this vector when you do your dot product and your vector resolute formula. So I can take any vector for b that is in the direction of this vector. So what I'll probably do is just take the unit vector. And again, like, this is where pen and paper is probably useful to just demonstrate that. You know, I'll draw a little vector A, vector B is in this direction. I don't know how long it is, but it doesn't matter. I know what I end up with is this one. So B just has to be parallel to this. So I could even take this vector itself, but I'll take the unit vector of it. 2, negative, what was it? 2, negative 1, negative 2. And I'm going to use this as my vector B. Okay, just again, I can use anything parallel to this vector resolute. Now I'm going to define that as B. I'm going to define A as what I was given for 3D negative D. And then I'm going to use my vector resolute formula, which is dot product of A and B over dot product of B and B times vector B, or there's the equivalent one which you can use as well. When I do that, I get this vector, which is everything in terms of D. That's good. And what I want, and I can just match up any of these coefficients. Hopefully, you know, we could use any one. So let's take the first one and solve when it's equal to 4. Solve for D, and that is negative 10. Now, I know that's not the right answer, and it's not even one of the options there. So what has gone wrong there? So what's going on there is the vector resolute should be this one, not A. So when I'm matching up those coefficients, I should be matching up the I coefficient to 2. Okay, so that gives D equals -1, so giving option A. Just to show, if I matched up the J coefficient, which was D minus 8/9, and I know that should be equal to -1, I should still get the same answer, which is good. All right, so question 14 is another vectors question, another angle between vectors question. And we got this vector 1, 2, 1 and the positive direction of the z-axis. So there's a few ways to do this one. What I would think is just take a vector that's like 1k and do your scalar resolute formula. So the cosine would be a dot b over b dot b, sorry, a dot b over norm of a, norm of b. So here a is going to be 1, 2, 1. And b is going to be 0, 0, 1. Okay, I just need any vector that's just in the positive direction of the z-axis and find the angle between those two. So I'm going to do the inverse cosine of dot product of a and b. And on the bottom, the norm of a times the norm of b. Norm of b is just going to be 1. But anyway, and what do we got? Inverse cosine root 6 over 6, so option D. I'm not going to do the mechanics questions because given that you're going to be sitting your exam in 2023 or later, you're not going to be sitting questions on mechanics. If you are interested in mechanics, I apologize, but let's skip those and move on to question 18, which is a statistics question or probability question. Typically spans, I assume they mean that's the average. The mean is 100 on maths and 40 minutes on reading. Standard deviations are 12 and 5. Assume the two tasks are independent and normal. We want less than 120 minutes on a total. So we would be defining a variable, which is the sum of the maths and the reading. The mean of that is just going to be 100 plus 40, that's 140. We'll get the variance first, just using the variance formula. So because we're just summing here, like x plus y, the variance is also just going to be variance of x plus variance of y. So that's 12 squared plus 5 squared. And I know that when I square root that, I will get 13. So the standard deviation of my sum is going to be 13. We'll use a normal CDF. Between -infinity to 120, mean we said was 140, and standard deviation 13. So the probability would be 0.06, it's option A. This one, a random sample of 50 passengers, has a mean mass of 73, that's an x bar, and a standard deviation of 8. I want a 95% confidence interval. This is another good one for the CAS, just menu, statistics, confidence intervals. We want a Z interval. We just choose stats and type in all the information we've been given. Sigma is 8, X bar is 73, N is 50, and we want a 95% confidence interval. Control Enter, and option A, it's a gimme. This looks more like a pen and paper question, but x and y independent random variables, each of which has mean m variance v. The standard deviation of z, which is px plus qy. So it's a sort of similar question to question 18. It's a sum of variances, sum of random variables question. We just need the standard deviation. So what I'll do is just use the variance formula. So the variance of z is going to be p squared times the variance of x. That's p squared times v, and the variance of q squared times the variance of y, which is also v. Q squared times v, and that is the variance. So for the standard deviation, we then want to take the square root of that. And there we are, it's option B. Okay, so we got pretty far with just the CAS, and well, of course we did have to know what we were doing. We had to do a little bit of thinking, but you know, using the CAS to your advantage makes sense, given that you've probably got to do it faster than what I've done it here if you want to get all of those within 30 minutes. You know, if you're having trouble with one, just make a guess, move on. You can always come back to it. You don't want to spend more than 30 minutes because you want to have enough time to get onto the extended response question.